For millennia, one side of the moon has remained hidden from human eyes, a silent sentinel forever gazing out into the cosmic abyss. What secrets does it hold? What stories lay etched upon its desolate, crater-scarred surface? For much of human history, these questions were left to the whims of dreamers and the imaginations of storytellers. But now, we stand at the precipice of discovery, ready to pierce the veil of the unknown and uncover the truth held captive by the far side of the moon. Are you ready to journey with me into the darkness? We gaze up at the moon, a beacon in our night sky, and we see the same familiar face staring back. But why? Why does the moon always show us the same side? The answer lies in a celestial dance, a gravitational waltz between our planet and its faithful companion. You see, the moon is tidally locked to the Earth. This means that the time it takes the moon to rotate once on its axis is the same as the time it takes to orbit our planet. This synchronous rotation, this cosmic choreography, is what keeps one side perpetually hidden from our terrestrial vantage point. Now it's important to understand that the term dark side is a bit of a misnomer. It's not that the far side of the moon is perpetually shrouded in darkness. It receives just as much sunlight as the side we see, just not at the same time. But the lack of direct observation for so long fueled speculation, didn't it? Whispers of hidden alien bases, of secret structures built by ancient civilizations, all lurking just beyond our sight. The human mind, you see, abhors a vacuum, especially one filled with the darkness of the unknown. The far side of the moon became a canvas onto which we projected our hopes, our fears, and our boundless capacity for wonder. And who could blame us? After all, isn't it in the shadows where the most intriguing stories often reside? But we are a species driven by curiosity, by an insatiable thirst for knowledge. We don't simply accept the shadows, we seek to illuminate them. And so we sent our emissaries into the void, our robotic scouts to pierce the veil of the unknown. The first tantalizing glimpses of the far side, grainy images beamed back by the Soviet Luna 3 spacecraft in 1959, only deepened the mystery. They revealed a landscape starkly different from the familiar face we knew. A landscape dominated by craters, vast plains of solidified lava, and a profound sense of otherness. But those early images were just the beginning. The Apollo missions, those daring leaps into the unknown, gave us our first orbital views of the far side, and with each orbit, with each new photograph transmitted back to Earth, the truth began to emerge from the shadows. And what have we learned? What secrets has the far side of the moon finally revealed? Well, that's a story for another chapter, one that speaks of ancient impacts of the very building blocks of our solar system, and the tantalizing possibility of hidden resources that could fuel our future among the stars. Our journey to understand the moon's far side is a journey back in time, a retracing of the violent steps that shaped our early solar system. The near side, the face we see, is dominated by these dark, smooth maria, these vast ancient seas of cooled lava. But the far side tells a different story. It's a landscape absolutely riddled with craters, pockmarked and scarred by billions of years of impacts. Each crater you see is a cosmic fossil, a record of a collision with an asteroid or comet. And the far side, well, it wears its history on its face, so to speak. Why the difference? Why is the far side so much more heavily cratered? Well, one leading theory suggests that the lunar crust on the far side is thicker, making it more resistant to the lava flows that smoothed over the near side. So, those early impacts, those cosmic scars, remain more visible, a testament to the chaotic early days of our solar system. And then there's the South Pole Aitken Basin, one of the largest known impact craters in the entire solar system. Imagine a crater so large, so deep, that it stretches across nearly a quarter of the moon's surface. It's a colossal scar, a testament to the unimaginable forces that shaped our cosmic neighborhood. Now, exploring the far side isn't just about gazing back into the past, it's about understanding the possibilities the future holds. Take the lunar regolith, the fine, powdery dust that covers the surface. Analysis of samples brought back by the Apollo missions revealed a tantalizing clue: the presence of water ice, locked away in the permanently shadowed craters at the lunar poles. Think about that for a moment. Water ice on the moon. It's a game changer potentially. Water, as we know, is essential for life as we know it, but it's also a valuable resource for future lunar explorers. Imagine one day using that lunar water ice to create rocket fuel, to sustain lunar outposts, to enable humanity to establish a permanent presence on the lunar surface. The far side, once a symbol of the unknown, could become a stepping stone, a launch pad for our species to reach out further into the cosmos. Chapter 3. Beneath a silent surface. We've begun to map the surface of the far side to read the stories etched upon its face. But what lies beneath? What secrets are hidden beneath that desolate, cratered landscape? Well, the moon holds its secrets close, but we're beginning to listen in, to eavesdrop on the whispers of its geologic heart. Take, for instance, the possibility of lava tubes. Imagine, if you will, vast underground tunnels, carved out eons ago by flows of molten rock. These lava tubes, shielded from the harsh radiation and temperature extremes of the lunar surface, could offer a natural shelter for future lunar habitats. Think of it, entire lunar cities thriving beneath the surface, protected from the ravages of space. Imagine gazing up through a dome at the star-strewn blackness, the Earth a distant sapphire-blue beacon in the cosmic night. And then there's the matter of helium-3. This rare isotope of helium, virtually non-existent here on Earth, is found in abundance in the lunar regolith. Now, why should we care about helium-3? Well, my friends, helium-3 holds the potential for a clean, nearly limitless energy source through nuclear fusion. Imagine a future where power plants fueled by lunar helium-3 light our cities, a future free from the constraints of fossil fuels. Of course, these are just possibilities. Tantalizing threads we're just beginning to unravel. But the far side of the moon, with its unique composition and its hidden depths, offers a treasure trove of scientific and technological potential. And who knows what else we might find? The moon, after all, is an ancient celestial body, and it's seen more than its fair share of cosmic history. It's entirely possible that the far side holds clues to the very origins of our solar system, secrets waiting to be unlocked by intrepid explorers and curious minds. But exploring the far side isn't just about uncovering scientific mysteries, it's about pushing the boundaries of human ingenuity. It's about daring to dream bigger, to envision a future where humanity has a permanent foothold on another world. And the far side of the moon, with its isolation, its silence, and its unique advantages, offers a tantalizing glimpse of what that future might hold. Chapter 4. A silent stage for a giant leap. Throughout history, humanity has gazed up at the night sky, searching for answers, for meaning, for connection to something larger than ourselves. Now, as we stand on the verge of a new era of space exploration, the far side of the moon beckons, offering a unique destination for our next giant leap. Imagine a world bathed in perpetual radio silence. The far side of the moon, shielded from Earth's radio waves, is ideal for radio telescopes. These telescopes could peer deeper into the cosmos, unlocking secrets of the early universe and listening for distant civilizations. We've become adept at polluting our planet with light and sound, but the far side of the moon offers a pristine environment for scientific instruments. And then there's Mars. The far side of the moon could serve as a testing ground for our journey to the red planet. Imagine lunar outposts, constructed using 3D printing technology and lunar resources. Picture astronauts training in the moon's lower gravity, preparing for Mars. The far side could become a launch pad for humanity's next great adventure. Landing on the far side of the moon would stand as a testament to human ingenuity. It would signal to the universe that humanity is ready to venture into the vast cosmic ocean. The far side of the moon can become a symbol of our ambition and our belief in the power of the human spirit. It's a silent stage, waiting for us to write the next chapter in our exploration of the cosmos. The question is, are we bold enough to accept the challenge? Are we ready to venture into the unknown and claim our place among the stars? The answer lies within each and every one of us, for the spirit of exploration is woven into the very fabric of what it means to be human. Outrow a new moon rising. For centuries, the far side of the moon was a place of mystery, a blank canvas onto which we projected our fears and our fantasies. But now, as we begin to explore it, are we ready for what we might find? The far side is no longer a distant, unknowable place. It's a new frontier, ripe for exploration, discovery, and perhaps even revelation. It's a place where we can push the boundaries of science, technology, and the human spirit. What secrets does the far side hold? What wonders will we uncover? The journey of discovery is just beginning, and who knows, Perhaps one day, you'll be the one standing on that silent surface gazing up at a sky filled with the light of a billion stars, and you'll be the one to unveil the next great mystery of the moon's far side.